One thing. What's that?
You gotta find the one.
You want the graph those points on number 8?
I didn't give you a, no. Stay right there. All right, let's see. So let's try this first one out, number 7. This, hopefully, everybody's on board with, just how to find these things. Negative 3, 5. Where would I go? Yeah, 1, 2, 3, and then up 5. So there's point A.
I'm sorry.
That's all right. 4, 0. How do I get there?
You go for
Yeah, the first number is left and right. So I go right 4, and then up or down 0. So I just stay right there. So any point on the x-axis will be something, comma, 0. Because if you don't go up or down, you're still going to be on this axis somewhere. Does that make sense?
Yeah.
Every single point in there is going to be something, comma, 0. Every single point on this one is going to be 0, comma, something. Same reason. Okay. Did I kill myself? That's good. C. How do I get there? Negative 2, negative 5.
Left 2.
Yeah, back 2.
Down 2.
Down 5.
Down 5. I like it. And then part D, 0, 3. Yeah, don't go left and right at all. Only go up 3. There's that 0, comma, something. That's on the y-axis. 0, 3. That's D. I like it. So when I give this to you on the test, make sure you put your little letters next to them, because nothing's more annoying than trying to figure out which point is the one you meant. Right? So put A, B, C next to it. Or it's going to drive me crazy. And that's the last thing you want me to do is when I'm grading your test. Number 8. Now this one I gave to you. We hadn't really talked about it, but I wanted to see if you guys realized we solved equations before, and then we checked solutions. That idea never changes. How do I check a possible solution? I just put it back in. And if it's true, it works. It's a solution. So when you plug in negative 3 for x and negative 8 for y, 4 times negative 3 minus 3 times negative 8 equals 12. I get negative 12 plus 24 equals 12. Check. So A is yes. What about 6, 4? 4 times 6 minus 3 times 4?
24 minus 12.
Yeah, 24 minus 12 is 12. Check. Yes, B is good. What about C?
4 times 0 minus 3 times negative 4 is 12.
So I get 0
Plus 12.
plus 12.
Equals 12.
Check. C is yes. And then D.
4 times 12 minus 3 times 12
48
is
minus
12.
30.
48 minus 36.
Now look at another way, real quick. Another way to look at this. 4 12s minus 3 12s
112.
is 112. 11. So that's another way instead of making it all 48ers. So yeah, I made them all answers. I don't remember meaning them, but all
Do we have to do all
They're
that
all yes.
when we do the test? Or?
Yeah, so if I would have come up, yeah, you got to do all that. That was a lot of work. If you think it's a lot of work, I'm really sorry for you for next semester. All right.
Remember the syllabus for number 9.
Oh yeah, number 9, real quick, just because it was in the middle of everything. What's the formula that relates those?
A squared plus B squared equals C squared.
And which side is the most important to figure out?
C squared.
C. And which one? Yeah, it's always going to be the one across from the right angle. So it's got to be A squared plus B squared equals C squared. C squared's got to be X squared. C has got to be X. And then the other two are just A and B. Who cares? So we get 3 squared plus 5 squared. 9 plus 25 equals X squared.
Which is, what I think,
34 equals X squared. So what's X?
34
between 6 and 5.
How do you undo a square?
square root,
Take the square root. So the answer is square root of 34.
which is 5.83. 3.
Good. So on a test, I might say, give me the exact answer and an approximation from your calculator. Right? So you got 5.83, blah, blah, blah. Blah, blah, blah. Okay, cool. So that's number 9. I didn't ask you to do that, but just because it was sitting there. Number 10. Somebody help me out. What points did you try?
-1.
All right, so if you plug a -1 in,
We got 5.
you get -2 times -1 plus 3. 2 plus 3 is 5. I like it. God, I can't remember.
0.
So if you try 0, I get y equals 0 plus 3.
Faint.
1. So those are beautiful. Those are the 3 you almost always try. Now, if I put -1 in and I get 120 out, I'm probably not going to use that point. You with me? You don't have to use every point you find. And one thing I want to make really clear. Let me be clear. A line exists. It just exists. And what we're doing is we don't see it. We haven't made it. We don't. But it's sitting there. So we go find certain points. When I plug that in, I get that out. When I plug that in, I get that out. So just because somebody else found this point and that point, you're both going to get the same stupid line. You're both talking about the same line. Who cares which points you get when you connect them? They're going to go through every damn point you could have done. Does that make sense? Sounds like good. I like the discussion that was happening there. Okay. So here, when you plug in a 1, what happens?
We got 1.
I got it. You get 1. I like it. So y is 1. So then I can graph those 3 points. So -1, 5. I like it. There's that one. 0, 3.
Up 3.
Yeah, don't go anywhere that way. Up 3. And 1, 1.
Over 1, up 1.
You almost can't go wrong there. Did anybody else get a different point? When you do 2, what do you get?
-1.
See here, 1, 2, -1. Bam! I got that point 2. Man. So when you fill in the line, you're doing all the other points you could have done. All the weird-ass points. And again, I could plug square root of 7 in there. And it's going to have something come out, but I'm going to catch it when I make my line. So why would I do that to myself? I'm going to make it nice numbers. Because that's all I need is a few representative numbers. How about part B? You can do that one a little bit differently. That one should go a little quicker.
3, 4, 5.
5
Yeah, it could be like 5
and 3.
and 3. Right? 5 minus 3 is 2.
4 and 2, 3,
4 and 2.
3 and 1,
3 and 1.
6 and 4.
2 and 0. 1 and... I like it. Well, then negative. Let's be quiet though. Because this goes down by 1. This goes down by 1. You see that? That's the pattern that it's set up. You wouldn't necessarily know that going in, but you can see it when you start making a few numbers. So what do I want to graph here? All these would work actually. So if I graph 5, 3. Is that cool? It's 5, 3, 4, 2, 3, 1, 2, 0, 1, -1. So there's my line. And when I make it, it captures all the other possible answers. So when you make a graph, you're actually giving an infinite number of solutions to an equation. That's kind of neat. Or not. Okay. So how are we doing with that? That's section 8.3 and 8.4. That's what they have there.
What's up for section 9?
Chapter 9, I'm going to make chapter 9 extra credit. So if you want to do chapter 9, you guys with me? It's extra credit. You guys all hear that?
Sounds good.
You'll notice there's no chapter 9 questions on the practice test. Because if I do put any on there, they'll be in the bonus. So if you do chapter 9, you get extra credit for the homework, plus you get ready for the bonus question, get some extra credit on the test.
So it has to give you an effective code, right?
What's that?
The test?
Yeah?
Give you what section?
6.3 through 8.4.
Can you review a fraction into decimal?
Not right now. Remember, this Thursday is review day for the test. I got one last thing from chapter 8 to talk about, and then we're going to head out. Let me show you a strange equation. Oh yeah. Graph the given equations on a rectangular coordinate system. Good Lord. What's weird about this equation here compared to what we've been doing? What's weird about it?
X equal 2.
There's no y. I love it. Whoever said that. It's almost too obvious. Everybody else is like, yeah, there's no y, but I think it was just that. So what that means is y can be whatever the hell it wants to be. What does this equation says? What does it say must be true?
X.
Equal 2.
Must be 2. What can y do? This equation says nothing, so y can go insane. But anything you plot has to have x is 2. So if you want to make a table, it's almost silly. Y can be anything you want, but x has to be
2.
So what do you want y to be?
Negative 1.
0. What's x?
2.
2. What about y was negative 3?
2.
2. What if y was 9? 2. What if y was 4? Okay.
And
Does that-
still plot to a straight line?
Exactly. Let's try it out. 2, 0. Where's 2, 0?
It's amazing, dude.
Where's 2, 0?
2 to the right. That's it.
And where's 2, negative 3?
Down.
2 to the right, down 3. And where's 2, 4? Let's do that one.
2.
Oh.
So then my line, if I can make it straight.
Isn't that weird?
But I want you to really see, this line can only go up and down because x is left and right, and x has to be 2. It can't go left and right. So what's the only way this line can go?
Up and
So what
down.
does it do? It goes up and down forever. You would call this infinite slope. This is like climbing up the side of a mountain, straight up. And of course it goes like that, and then you go. So what do you think is going to be true about an equation like y equals something?
This could be the opposite of what you just explained. Instead of going up and down, it's going to be sideways.
I love it. You're partially trying to be smart, but you're right. Y equals 5. 1, 2, 3, 4, 5. Y's got to be 5. So is x, if x is 1, y's got to be 5. Right? That's what the equation says. X is x constrained. Does the equation say anything about x? No. X can go wild. So if x is negative 1, y is
5.
5. If x is 0, y is
5.
5. If x is square root of 11,
5.
y is 5. I like it. So then you get like that. Cool. So y equals is going to be flat like this. It's going to be horizontal because it's not allowed to move up and down. Y is not allowed to change, so it can only go left and right. It's the exact opposite of this one. So those are two special cases. They should be really easy. If you realize a letter is missing, it should be easy. You shouldn't have to do a lot of work.
And that's graphing given equation.
Yeah, I mean, this is a special type. So what we've been doing is this. I just haven't set it all the way out. Yeah, that's what we've been doing. This is just a special kind of an equation. It's a special case. It's missing a letter. And that's all I got.
That's it.
That's it? That's plenty. So we're not going to do any more new stuff. It's crazy.
We're done.